So if you've ever wondered how it is that we come up with this value of absolute zero, here it is here, 0 kelvins, is being equal to minus 273.15 degrees centigrade, we're going to try to explain that here. And we're going to use Charles' law, which we spoke about in another video, where we have the volume at some temperature is equal to the initial volume plus a correction. And that correction, the way Charles wrote it, is that we have that same initial volume multiplied by the coefficient of thermal expansion, multiplied by delta T, some heating or cooling. Now, if our reference temperature, let's say delta T, is equal to the temperature of interest minus T naught, if that temperature of reference is 0 degrees centigrade, then we can just simply call it T and drop the delta, and it could just be Vt is equal to V naught plus V naught alpha T. Let's take a look at Charles' experiments. He would take a volume of air and he would heat it up or cool it down and watch the volume either increase as the material was heated or shrink as the air was cooled down. And he determined a value experimentally of a coefficient of thermal expansion for air of 37.45 times 10 to the minus 4 per degrees centigrade. Now, we're going to play a little mathematical game. We're going to do this. We're going to say that since this is a 1 over temperature interval, let's just write it like this. Let's say that we have this value alpha, let it be 1 over T. So is there some temperature T naught such that we can get this value of alpha of 37.45 times 10 to the minus 4? If we rewrite Charles' law, then it would be V at some temperature is equal to V naught plus V naught times 1 over T naught multiplied by T. So remember that this is simply equal to alpha. And we're just curious about what value of temperature, what value temperature here would allow us to recover this value for air. And it ends up that if T naught is equal to 267 degrees centigrade, then that will give us the value that Charles obtained. So, and we get that very easily, just the 1 over the thermal coefficient, expansion coefficient of 36, no, excuse me, that's the modern value. We'll get to that in a moment. 37.45 times 10 to the minus 4 over degrees centigrade. If you just take the inverse of that, then you would get 267 degrees centigrade. So if we put that back into Charles' law, you see this. We have an initial volume, and it ends up that now it really doesn't matter what it is. If we have a value of T such that it is equal to a cooling of minus 267 degrees centigrade, then it would cancel out this value, and this entire product would be equal to minus 1. So to get this product to be minus 1, you can insert the value of alpha of 37.45 times 10 to the minus 4 per degree C, or equivalently, you could do the 1 over T naught, where it's 1 over 267 degrees centigrade. These are the same. So Charles discovered that there must be this lowest possible temperature, otherwise we would have volumes that are less than 0. So if you accept that volumes cannot be less than 0, if volumes cannot be negative, then there must be some lowest temperature below which you cannot go. And that would be a function of whatever the value of alpha is. Coming back to the modern day, we'll take the modern value for air. It is 36.61 times 10 to the minus 4 over degrees centigrade, not too far away from Charles's value. And if you take 1 over alpha air using this modern value, you would get 273.15 degrees centigrade. That's a positive value. And so if the temperature of cooling, the delta T, were 273 degrees, 273.15 degrees centigrade below zero, then this would cancel out, or excuse me, it wouldn't cancel out. It would give us a product of -1. So we would have Vt is equal to V naught plus V naught alpha T, where this would be -1. And then the right-hand side would go to 0. We would have V naught minus V naught. And we should not be able to have any volume smaller than that. So if there's an absolute lowest volume, which would be 0, allowing the volumes cannot be negative, then there must be an absolute lowest temperature, and that lowest temperature would be -273.15 degrees centigrade.